Recently, Arduino released 4 new boards. They all look very similar, but use utterly different microcontroller chips. So we have to answer 2 questions. Do they know what they are doing? And is it any good for us makers? And of course, how do they compare with the ESP32? Grüezi YouTubers, here is the guy with the Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Remember, if you subscribe, you will always sit in the first row. In this video we will look at these 4 new boards. The Arduino Nano Every, the Nano 33 IoT, the Nano 33 BLE, and the Nano 33 BLE Sense. And we will look into the following topics. An overview of the capabilities of the boards. We will also add a typical ESP32 board for reference. We will have a look into how the Arduino IDE supports a multi-CPU architecture environment. I'm sure we will find out bad things about the boards if they exist. We will test the BLE and the Wi-Fi functions and measure power consumption. And we will try to answer the essential questions. What are the implications for the future of the Arduino platform? And is there a new star born? Let's start with the past. Over a very long period, all Arduinos used the same or very similar microcontroller chips, short MCUs. This made life easy because during programming we only had to select the board and everything went smoothly. Libraries, with a few exceptions, were compatible with all Arduino boards. Then came some crazy developers and hijacked the Arduino IDE to be able to program other chips like the ESP8266 and, on a smaller scale, STM chips. Arduino also created the DUE, which used a completely different processor. To deal with this situation, a board manager was introduced. Its significant advantage is that we can program various MCUs with the same Arduino code and that we do not have to learn a lot of new stuff. All this happened a few years ago. You see that fact if you go to your boards menu. Here you find all installed MCU architectures. It starts with the Arduino SAMD, where you find the new Nano 33 IoT. It goes on with the Mega AVR, where you find the Nano Every. Then in the Arduino NRF528X section, you see the Nano 33 BLE, which is also good for the Nano 33 BLE Sense board. In the Arduino AVR section, you find all old boards. None of the new boards is classified here. Then we go on to the Arduino ARM, the ESP32 and the ESP8266 boards. Of course, these sections are only shown if you installed the respective packages in the boards manager. Another important thing is the libraries. Often, libraries are no more compatible with newer architectures because these new chips work entirely different. In the past, we often needed a different library for each board. And in the beginning, many libraries were not available for the ESP8266, for example. Since then, libraries were adapted to the different MCU architectures and often can be used for many or all board architectures. The ESP8266 certainly got the most adapted libraries, but many of them were also adapted to the ESP32. So far, I did not check if this is also true for the newer SAMD or NRF52 architectures. Maybe you can contribute your knowledge if you work with these chips. So, the first learning is, before you decide on one of the new boards, try at least the intended libraries by compiling an example file for the boards in mind. If you get compilation errors, you can't forget it. If not, you might be lucky and the library works. No guarantee, though. But why did I show you all these things under the hood? First, you have to know it if you decide to work with the new boards. But second, and probably more important, These developments open entirely new possibilities. As we saw before, Arduino presented 4 different boards with 3 utterly different processor families. This would have been impossible in the past, and it might be risky today if library support would not be suitable. But they did it, and they are now responsible for adapting at least the most important libraries to all these new boards, if not already done. And we can assume Adafruit as the second significant library contributor and also an Arduino reseller will also adapt their libraries, if not already done. So we can go on to check out what the new boards are before we come back to the question: what does this mean for the maker scene? There are still a few things we have to consider in this new world. The first is the voltages. All Arduinos were 5 volts and all sensors were 5 volts too and therefore compatible. This was a perfect world. Today we have to pay attention. Most of the newer boards are only 3.3 volts. Some, like the ESP8266, at least can be connected to 5 volt periphery. But others, like the Raspberry Pi, can be destroyed if we connect their pins to 5 volts. The same applies to the new boards, except the Arduino Nano EVRY. It works on 5 volts and accepts 5 volts on its pins and therefore is highly compatible with the old Arduino world. All other boards can be destroyed if you connect 5 volts to any of their pins. This is why these boards have a 33 in their names. Because newer sensors anyway work on 3.3 volts, I hardly use 5 volts in my projects anymore. But we had to pay less attention to this fact when we only used ESP8266 chips, because their pins are 5 volts compatible. I am not sure how the situation is with the ESP32. The comparison of all boards show that the old Arduinos use 8-bit CPUs. These are okay but can be quite slow, especially if you have to do calculations. The new boards, except the Arduino EVRY, use 32-bit CPUs. The ESPs used 32-bit right from the start. These CPUs are much faster and usually also have more memory. If we start with memory, the ESPs still have way more memory than the rest of the boards. This can be important if you want to do over-the-air or OTA updates. Next, the CPU cores. All Arduinos have one core. The Nano 33 IoT has a so-called M0 Plus core, which is slower than the M4 core used in the EVRY 33 BLEs. And the ESP32 has 2 cores. Here you see a comparison between the 2 ARM cores. The M4 core supports many more floating point operations. So the 32-bit boards are clearly better than the rest in memory and speed. But I did not do any benchmarks yet. Next come the connection possibilities. All new boards have the needed connections like serial, I2C, SPI, analog and digital GPIOs. The 32-bit boards have 2 or more serials, which is handy for debugging. You can connect serial 1 to your sensor and still can use the serial monitor for debugging. The ESP32 and the BLE Arduinos offer I2S support, which can be used for audio applications. If you want to know more, you have to dig into the datasheets of the different boards. A significant difference is USB. While all old Arduinos, including the Nano EVRY and also the ESPs, do not offer native USB, the Nano 33 IoT and the Nano 33 BLEs offer this functionality, at least in hardware. If we remember, the Arduino Leonardo introduced this functionality, which can simulate a keyboard or a mouse. To test this functionality, I tried the keyboard.begin command, and it worked on the Nano 33 IoT. It did not work on the BLE models. Maybe it will be implemented later. Next comes the supply for power. The old Arduinos and most ESPs use linear regulators, which can be used up to about 8 volts before they get too hot. The new Arduinos all use a switching regulator which can be used up to 21 volts input and can deliver 1.2 ampere. This is the right choice if you want to connect a module, for example, directly to a 12-volt battery. The quiescent current is only 200 microampere. Not bad, but for BLE applications it might be too high. But for sure you will have enough power also for your sensors or even some LEDs. As expected, the regulator of the Nano EVRY outputs 5 volts. Then they added a 3.3 linear regulator for compatibility reasons. All other boards produce only 3.3 volts. Their 5-volt pins are somehow connected to the USB plug. One thing I detest is if I cannot read the pin names on the silk screen. We are makers and have to work with our boards. All Arduinos have the pins marked with a good quality silk screen, but unfortunately on the bottom side of the board. If you solder headers to the modules, you cannot see them anymore. The only way you can avoid that problem is to solder the modules upside down, which is probably possible if you do not want to use the reset button. Or you print the layout and laminate the paper as I did with some other vital information. And another small trick to keep your blood pressure low. You always get this error message when you try to upload your sketch to the Nano EVRY. It took me a while to find out that this is only a warning and can be ignored. I hope it will disappear in one of the next versions. When I got the boards in my last mailbag, I complained about not finding enough information. This changed and I found the board definitions as well as the libraries for the different sensors on the boards. So we can check out the functionality which matters most for me. I want to know if BLE works, because Nordic Semiconductor, the manufacturer of the nRF52 MCUs, is well known for its BLE and low power chips. Frequent viewers know that I was disappointed by the BLE functionality and especially the power consumption of the ESP32. The nRF52840 chip should be a clear winner in this respect if Arduino did a good implementation. So let's test and load the BLE server sketch called Battery Monitor on the Nano 33 BLE without sensors. Like that, we should get minimal power consumption. The sketch measures battery voltage and transmits it over BLE. We can receive the signals using our smartphone or the Raspberry Pi. Unfortunately, I was not capable of transferring data to an ESP32. It connected but refused to receive data. Only the BLE god knows why. Or maybe you know it? During the compilation of the BLE example, I have time to tell you another not so lovely thing. The compilation time is exceptionally long for the nRF52 boards. It is not seconds as with all other boards. No, it takes 2 full minutes for every compilation and upload for the BLE Battery Monitor example. I feel like in the 1980s, where we had to wait till our EEPROMs were erased by the UV light. If you do not know what I'm talking about, you can watch my last video about old chips and how all began. You find a link in the description. Now the sketch is uploaded and we are ready. The Arduino waits for a connection and we see Battery Monitor in the NRF Connect on the iPhone. As soon as we connect, the Arduino starts to transmit values and we can read them on the smartphone. Cool! But how much energy the Arduino consumes? According to the Joule scope, it is 22 to 24 mA with a power LED off. There are no high current peaks as with the ESP32. This also is a good sign that Arduino did an excellent job on filtering power. As expected, this module consumes much less than the ESP32. But the 22 to 24 mA is still way too much for a BLE device. Typical BLE beacons or sensors run many months on a button cell. According to the datasheet, the NINA B306 module used on this board only consumes 4.9 mA maximum, with standby and sleep modes in the microampere range. I would be glad to get an example file that uses these modes to reduce power to normal BLE levels. You might remember I ordered two BLE boards, the Nano 33 BLE and the Nano 33 BLE Sense. The boards are the same. The only difference, on the Sense board the sensors are populated. Having such a density of sensors is handy because you can save time and a lot of space if you want to experiment with one or more of these sensors. The price for the Nano 33 BLE Sense seems to be okay if you can get a decent shipping cost. And if we get examples on how to use this board at BLE power consumption levels, this would be a perfect deal for all who are interested in BLE and sensors. Let's now have a look at the direct competitor to the ESP32, the Nano 33 IoT. It uses a full ESP32 just for Wi-Fi. Its central processor is a SAMD21, which is much weaker than the ESP32 and also has much less memory. But this concept has the advantage that you are sure that Wi-Fi traffic is not influenced by your code. The disadvantage is that from time to time you have to update the firmware of the Wi-Fi module. You get the needed tools, but it creates additional work. The power consumption of this module clearly is dominated by the ESP32, which creates the usual peaks of more than 250 mA and an average current of around 80 mA. Something interesting happens in this sketch. It fetches the NTP time and then it executes a delay 10 seconds. During the delay, the whole module only consumes around 50 mA. This means that the ESP32 has reduced power consumption during this time. All my ESP32 boards consume more than 80 mA even without Wi-Fi activity. Very interesting. Just that you do not need to search too long. For this module you have to install the Wi-Fi Nina library, which has its name from the Nina Wi-Fi module manufactured by u-blox, the same company which is well known for its precise GPS chips, and which is located in Switzerland. Just saying. I promised to come back to the question, what does this mean for us, the makers? In the past we had to use different development environments for each processor architecture and learn new tools. If we decided to use the Arduino IDE, our choice was quite small. We were delighted when, with the ESP8266 and later the ESP32, our choice for chips was extended. And now this. I read this Arduino announcement as a clear statement that our selection of MCUs gets bigger and bigger. And if we look at other major maker companies like SparkFun or Adafruit, we see precisely the same thing happen. They extended their choice of MCUs on their boards. And if we look at Platform I/O, there these new chips are also supported, even with free inline debugging. I do not care too much about the SAMD21 or 51 chips, because they are not connected devices. But I care a lot about the NRF52 line. These chips are low power and connected. This can be an improvement over the ESP32, especially if you want to use BLE. Maybe the next star is born? The Arduino Nano 33 BLE costs $19.50. The u-blox modules alone cost less than $10 in large quantities. And we already see Chinese modules for less than $5 on AliExpress. What do you think? Summarized, we saw how the support of the Arduino IDE evolved from a single CPU architecture to a multi-CPU architecture. We saw the importance of libraries in this game. We also saw the importance of Arduino's decision to use several new CPU families for the maker ecosystem. We looked at the new 3.3 volt world and the dangers coming from this change. And we had a look at the different CPU architectures and saw that the execution speed, especially for complex calculations, differs from board to board. We compared the memories of the various boards and saw that the ESP32 definitely is a good choice if you need OTA firmware upgrade. We saw that all boards offer enough connectivity. It became clear that the Nano Every is a dinosaur because it was designed to be compatible with the old Arduino world. In my opinion, it is not needed. All Nano 33 boards offer native USB support, but only the Nano 33 IoT offers software support to act as a USB host. We had a look at the power supplies and saw that the new Arduino boards could be used up to 21 volts, which is a clear advantage. Unfortunately, we discovered that on all new Arduino boards, pins are marked only on the bottom side. They cannot be seen in typical maker situations. We tested the BLE functions and measured power consumption. The functionality worked, but the power consumption was disappointing. I hope we will get better software support in the future. We also found out that the compilation time for the BLE chips is uncomfortably long compared with all other boards. We also checked the Wi-Fi functionality and power consumption of the Nano 33 IoT board. It behaved as expected. For makers, ESP32 boards still are the better choice. For professional usage, arguments can be different because of the secure element present on this board. All in all, we learned that we entered into a new area where our MCU choices will be extended, which is an encouraging message. I still assume it will be a rough ride, as it was when we got the first ESP8266 chips. But especially for the Nordic chips, I'm pretty sure it will be rewarding. So stay tuned what we will see in future episodes on this channel. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. You find the links in the description. Thank you. Bye.